No.
Now, if you're watching this on YouTube, you try too. See if you can come up with the name of it before we talk about it. Okay, should we try this?
3, 4, 5 trimethyl.
The parent. You're coming up with the parent as octane? Does everybody have octane as the parent chain?
No. Septane.
Check this out. 1, 2, 3, 4, 5, 6, 7, 8 is the longest continuous chain of carbons. It is an octane. That was great. That was good. Shenzi. For the money. Good. Yeah, that's an eight member continuous chain there of carbon. So this parent would be octane. Are you with me on that? So now I'm going to just take a different color and let's just circle. So we have this thing as our parent chain right there. See, I told you this has a little hint of nasty in it. That was it. Now we have some methyl group. It looks like there's only methyl groups. There's a methyl group there. Did some of you think that was an ethyl group? Like two carbons there on the branch, but it wasn't. We have 3 methyl groups. So we're going to have to call that trimethyl octane, but we have to also identify where the methyl groups are. And so do we want to make this carbon number 1 in the parent or that carbon number 1 in the parent? The second choice, yeah, this one right here. So that we have 1, 2, 3. There's a methyl group on carbon number 3. There's a methyl group on carbon number 4 and one on number 5. See that? So the name of this thing would be 3, 4, 5. You're going to indicate it like that. If you have, like this would be called trimethyl octane. So we have to say where all these methyl groups are. 3, 4, 5 dash trimethyl. And then in the same word, octane. Shenzi, I am very impressed. You came up with that. Did anybody else have that? Did you recognize an octane with the parent? I thought I'd catch all of you. You're too good. Okay, now, after you've had a chance to look at this, and if you're writing it down, make sure that you can digest this. How did we go about doing that? We first identified the parent, the longest continuous chain. Then, and I think it helps to draw circles around the functional groups because you have to identify them in what they are and where they are. So there's 3 methyl groups. We know that's going to be then a trimethyl octane. And so where are they as well? That's the numbers that go out in front. I had a question last hour. You might be wondering the same thing. Is it possible to have 2 functional groups on the same carbon on the parent chain? Yeah, sure. If this one was moved right there, if that was there, that would be called 3,4,4 trimethyl. So that would say that there are 2 methyl groups on the 4th carbon. 3,4,4 trimethyl. You follow? Okay. Now, that one was nasty. This one I don't think is too bad. Go ahead and try to name this one. Got it? What's the parent?
Septane.
It's a heptane because there's 7 carbons in the parent chain. And then, of course, there's a bromo group on it. We call that bromo. Who's got the name? Go ahead.
2-bromoheptane.
We good with that? Seems so simple after we did that one. 2-bromoheptane. Sounds good to me. Okay, does anybody have any questions about that? All right. So this is all saturated compounds where you have all single bonds. So all of these end in ANE. If you had a double bond, it would end in ENE. Those are alkenes. And that's the last thing that we'll do today is let's take a look at unsaturated hydrocarbons. You have a double or triple bond somewhere in the parent chain. You'll notice with alkanes and alkenes, it's not enough to just say, okay, there's 7 carbons in here and there's a double bond. We can't just call that heptane. We need to indicate where that double bond is. So, you know, if the double bond were in that place rather than that place, that would slightly change the properties of the molecule. 2-heptene is different than 3-heptene. Are they real different? No. I mean, they're very close to similar, but very close to similar. They are similar, but you know, they do have different properties. They're not the same. They're not interchangeable with one another. So yeah, it is going to be necessary to indicate where the double bond is in the parent. Brian, we'll keep it rolling even as people come in. I know it's going to be a little bit chaotic, more so than we have had. Yes?
So, say there was like a double bond near the end, would you name it 2?
Near the end of this one?
Yeah.
We would call that heptadiene. The di in the middle of it would mean that there's 2 different double bonds in there. We're not going to see that in this chapter, though. You won't ever see, I don't know if you won't ever, but you're not going to be responsible for knowing anything about dienes where you have 2 double bonds in one molecule. Won't happen. Yes?
What if they have one double bond and one triple bond?
You won't have it. You won't see it. It's possible to have those kinds of molecules, but we're not going to deal with those. That's too much depth for us today. Did you have another one?
Yeah. So, if the double bond wasn't there, but instead it was at the end,
To that end?
Yeah, with the numbering,
You'd start with that carbon as number 1. Yep. Yeah, that would be 1 heptene. Yep. Okay, now what if I give you this one? We have an alkene that has a functional group on it. What's the name of this one? For those of you that have been here all hour. Show them how sharp you are, how much you've learned this hour, and how much they can learn too. What's the parent on this thing called? The parent is hexene. Not just hexene though. What is it? 2-hexene. Now, we have a kind of a dilemma. Do we make this carbon number 1 because of the methyl group? Or do we make this carbon number 1 because of the double bond? Yeah, what you wrote down earlier was the double or triple bonds always get the priority for the numbering. That's carbon number 1 because it's closer to the double bond. You follow that? So this thing would be 2-hexene, and since it has a methyl group on carbon number 5 in that parent chain, that would be 5-methyl 2-hexene would be the name of this thing. I'll write that down. 5-methyl dash 2-hexene, like that. This thing right here is the parent. That 2 has to be part of the name of the parent because you have to indicate where that double bond is. And then, of course, you have to say at the beginning where the functional group is in the parent.
So functionals always go first, right?
Yes, in the name. You always put the functional group first. Or you could also say that you always put the parent last in the name. Yeah. Juniors, how'd we do? Got all that? Good. Seniors, I told the seniors, they were not motivated. They're like, well, come on, we're going to do something. But now that you come in, would it have been nice to know what we were doing this hour? You look at that 5-methyl 2-hexene. What's that? Well, Brian has been good enough to record it, and so I'll pop that up on YouTube and we'll check it out. I'm going to go ahead and stop there. So let's go ahead.